Okay, so we are going to be solving this equation by using the state space approach, and these are the initial conditions that we have and the constants for the condition, and this is our input, right? So if you would like to make it, so you make a few substitutions here. I'm going to make x1 as x, and I'm going to make x2 as x prime or x dot. Then I differentiate the left hand side. What do I get? I gonna get x1 prime is going to be now equals to x prime, right? And I have x2 prime equals to x double prime. Am I right?
Yes, yes.
X double prime, right? So now if I want to make the substitution, let me write the original equation now. Original equation was that, and now I want to make a substitution one by one. If I want to see that substitutions how it goes ahead, uh, then x is going to be on the left hand side is going to be x2 prime, right? It's going to be now 1 by m is going to be retained as it is. There's no change to f of t. There's no change to f of t, and you have minus c by m as it is, but x prime is going to be now x2, right?
Yes.
X prime is x2, and I have minus k by m again. And what is x? X is x1, right? So now let me just write the input at the end, right? This is what? This is a plus, right? So I have a plus there, and this is one differential equation that I just obtained, and I need another differential equation which is right here in front of me, right? I just take it here, put it there, but I know that the x prime is nothing but x2. X prime is nothing but x2. I can see it from here, right? So I have modeled the second state space equation also. So these are the two state space equations that I needed. One is this, and another one was that. These are the two state space. And if I want to find out what is the value of a, so I'll insert an equation, go to matrix A. So this is a matrix A that I want. A was this. This is, what is this? K by m. This is, if I put it in the right order, it is going to be here. So x1, and this is actually 1 into x1. This is 0 into x1 plus, right? And again I have 0 into f of t. So that's what two equations. So if I want to write this first term here, how does it going to take the shape? It's going to be minus k by m, minus k by m, right? K is 10 and m is 1,
Minus 10.
so it's going to be what? Minus 10, and c is 1, and so I have minus 1 there, and again I have 0 there, 0 for x1 and 1 for x2, right? Now I have done with A matrix. I'll introduce one more for the B matrix, and the B matrix is again like that. It turns out it's going to be a row matrix, right? Design, introduce a row matrix. B matrix is going to be, how should I define the B matrix here? B matrix is going to be a column matrix, right? B matrix is going to be a column matrix, not a row matrix. So I take that here, put it here. So what's going to be the first item? 1 by m. I have 1 by m and 0, but what is 1 by m? It's just 1. So we have finished the 1 matrix. So I have now C matrix, and the C matrix is, what is that? C matrix is the output matrix. It is going to be row matrix. The first one I'm interested in finding out the value of x1 or x, so I put it as 1, and x2 I'm not interested. So what is x2? X2 is x prime, right?
Yes.
So okay, now I'll go to D matrix. D matrix is going to be 0, right? So we have defined all our matrices that we need, and now all we need to do is put these stuffs in the Simulink, right? But we need to know the initial conditions as well. Initial conditions for this problem is going to be, what are the initial conditions that we have? We have two initial conditions, one for x1 and another for x2. X1 is nothing but x and x2 is nothing but x prime. So the value for initial condition for x1 is going to be what? Introduce this, and IC value for x1 is going to be 0, right? And this is going to be 1. So we have finished doing all these things. Now you go back to the Simulink, and we'll close this old model, save model, yes, and now open a new model, come back here. What do I need to do now? Go to sources. It's a step function, right?
Yes.
I have a step function and everything is common, and my f of t is basically a step function. I'll just zoom this a bit. Okay, now what do I need to do? I need to make a step, go to continuous state space approach, take this, connect them up, and double click. What was the value of a? It was minus 10, right? And how much? Minus 1 and 0 and 1, am I right?
Yes.
Yes, minus 10, minus 1, 0 and 1. So value of b is how much?
1. It's a column matrix.
It's a column matrix, 1 and 0. So 1, 0, and c was what? Row matrix, 1, 0, and d was 0. Initial conditions. So you define your initial conditions now, 0 and 1, right? Now we have finished defining our initial condition. Now we go to sync, go to a scope, take that, connect this there, and we are done. Again, maximum step size, go to model configuration. I am going to choose a fixed step size, let it be there. Go to, where is this? It's okay. Fine. Has it taken or not? Model configuration 0, 0, 0, 0. Okay. We'll run this scope. Okay. The difference, Allah? Maybe we have made a mistake somewhere.
BC, both you take in column matrix.
Which one?
Matrix.
Where? Here. Oh, that's one second. State space, Allah. Yeah, we have made a mistake. See here, we have made a mistake. This is x2, this is x1. So I should actually be writing it as this is going to be 0, and that is 1, and this is what? Minus 10, and this is supposed to be minus 1. Now I think we will be correct. And B matrix is for the input matrix, Allah. So that is going to be what? I have a 0 here. This is for x1, and this is for 1 by m. 1 by m is going to be, so you are supposed to read it like that. Okay, read it like this. And D, again everything else remains the same, I guess. The value of C, yes, I am interested in x1, so now everything is proper. So 0, 1, minus 10, correct now? On this we have the solution. Fine.